Good morning, everyone. Welcome to today's Exploring by the Seat of Your Pants Hangout. My name is Joe Grabowski, and I'll be your host for today. If you've been following along this month, you know that we have been focusing on the theme of climate change. So talking to different climate scientists and explorers from around the world who are not only studying the events and trying to figure out what's happening around the planet, but also looking for solutions to help mitigate the problem. So I want to give a quick shout out to Environment and Climate Change Canada. Huge thank you for your support of these events that we are running this month. And then let's get to our main event. So I'm really excited. We've got James McClintock joining us. James is one of the world's foremost experts on Antarctic marine biology, and he's currently the Endowed University Professor of Polar and Marine Biology at the University of Alabama in Birmingham. So he has led 15 research expeditions to Antarctica over the past 30 years, and his research has been featured in places like National Geographic, Discover Magazine, multiple newspapers. There's even a spot, McClintock Point, a promontory of land on the north side of the entrance of Explorers Cove on Scott Coast of the Ross Sea, Antarctica, named in honor of his research. So James, it is so great to be stealing some of your time today to hang out with some classrooms. We're really excited to learn a little bit more, and of course, they're going to have lots of questions for you.
All right. Thank you, Joe. It's nice to be here. Welcome, everybody. So I've been working in Antarctica a very long time. Actually, I do an amazing thing when I'm in Antarctica. I put on a dry suit and I dive through the ice and study the marine life that's on the seafloor of Antarctica. And as you can see in this picture, it is beautiful to dive under the ice in Antarctica, one of the richest marine systems in the world. But an area of Antarctica that I've been studying and living at the last 20 years is called the Antarctic Peninsula. It's about 800 miles long, and it sits underneath South America. And it is one of the most rapidly warming regions of our planet. And that's what I want to tell you about today, is what it's like to live and work in this area of the world that is warming so quickly. So if you look at warming over time, if you went back about 13 years now, a lot of the warming was thought to be in the Arctic. You've heard about the polar bears having trouble and the ice melting in the Arctic. That's a big ocean up there and the ice is disappearing. But in Antarctica, we're discovering that this continent, it's a huge place. This is the size of China and India combined, that the western side of the continent and that Antarctic peninsula up there are warming, and they're warming quickly. And now we know that the ice shelves, these 1,000-foot thick layers of ice that are attached to Antarctica, are also beginning to melt. And that's where you see those red areas around the continent. You know, we have the largest current in the world that goes around Antarctica in the ocean clockwise, and that is beginning to warm, and those ice shelves are beginning to melt.
Sorry, James, can I just jump in for 1 second?
Absolutely.
Have you started the screen share yet?
No.
Oh, okay. I just wanted to make sure.
Okay. Am I supposed to?
Oh, no. Just when you're ready to share the presentation, you just have to start the screen share.
Okay. Well, I want to share the presentation, so let's do that.
Okay.
All right. So are we on the same page now? Can everybody see the map of Antarctica?
Yeah, we got it.
Okay. Well, let me just go back. Let's see if I can get this screen active again. All right. I'm going to real quickly go back and show the students what they missed. I thought they were watching me, and they weren't. All right. Is everybody seeing now diving under the ice in Antarctica?
Yeah, we're good.
Okay, you're good. So that's the picture of our group diving under the ice in Antarctica. Isn't that fantastic? Look at how many animals are on the seafloor. And this is that area of Antarctica I'm going to talk about that's warming, this Antarctic Peninsula. And this is the map that shows that the Arctic is warming very, very quickly. And it's only until recently that we began to really understand that it's not just the Arctic that's warming, but Antarctica, particularly on that side that's in orange, the western side of the continent, and that peninsula that extends upward there. And this is that photo I wanted you to see, that image of the ice shelves that are beginning to melt around the continent of Antarctica because of that large current. All right, so how much warming are we talking about? Well, about 20 miles from where I work, scientists have been taking air temperatures for over 60 years. And we know that there's been about, 10 degrees Fahrenheit of warming over that period of time, which is very, very fast. That's a very rapid rate for warming. It makes it as quick as the Arctic or even more so. So what does that mean? Well, I can tell you that when I first went to Palmer Station on the peninsula about 20 years ago, I would hear a huge crash about once a week. And the big glacier behind our station, it's called the Mar Glacier, would drop a big chunk of ice into the ocean. And we'd all run down the hall and watch the waves come down the bay. It was very exciting. And now, when I go to Palmer Station, like this last year, the glacier is dropping big chunks into the ocean a couple times a day. So the frequency of these crashing pieces of ice coming down is getting very, very high. In fact, almost 90% of the glaciers on the Antarctic Peninsula are now receding. They're losing ice. And this is a scientist that puts on a backpack. In order to measure the edge of the glacier, they go for a very long hike. And they have a special piece of equipment in their backpack. It's called a GPS. And that's talking to a satellite above them, and it's tracking their hike during the day. And then you can map where the glacier is and where that hike went. You can see in 2017, what was that, 2 years ago, the glacier line was drawn by that hike that scientists took. And look where the glacier was back in the 1960s. It was just behind Palmer Station. So the glacier now, you have to hike about a half a kilometer just to get to the glacier. That's how quickly it's disappearing. Here's a map that shows you from the air where the glacier was in 1975 and then here in 2013, and you can see how much has gone. And this is a very interesting map that shows areas where the glaciers are thinning, and there's an instrument that they use to measure this. So wherever you see those red dots, that's where the glaciers are thinning in Antarctica as the air temperature warms and they melt. And over on the left is Greenland, which is in our hemisphere. And that also is a continent that's losing ice very quickly. Now, this is a big glacier called the Thwaites Glacier that is breaking up very quickly. And scientists are concerned about this because that 2 to 3 mile thick ice that sits on top of Antarctica moves from the west down through that area where the glacier is. And that ice that's sitting on top of Antarctica, if you can imagine 3 mile thick ice on top of a huge continent. In fact, that's where about 70% of the fresh water on this planet is located. That ice is moving. And that ice, when it moves from the continent and into the ocean, it causes sea level rise. And that's why we're concerned about that movement of ice. It affects us here back in North America, where sea level is rising. These are ice shelves. This is a map of the ice shelves that are breaking up as it's warming. And I'm just going to show you a couple of them. This is the Larsen B ice shelf. It was taken, a picture of it was taken on this date in 2002. And you can see that it's starting to break up. And a month later, the whole Larsen B ice shelf broke up and went out to sea. And this is a piece of real estate the size of the state of Rhode Island in the United States. I mean, that is a big chunk of ice. And remember, this ice is about 1,000 feet deep. This is the Larsen C ice shelf that recently broke up and floated out into the ocean, one of the largest icebergs ever recorded at that time. And that was the size of the state of Delaware in America. And over here, the Wilkins ice shelf is beginning to break up. And when this breaks up and goes out, and it will shortly, I think it's dangling to an island, that will be the size of the state of Connecticut. So these are very big breakups of ice. The good news is that when ice that's in the ocean, like these ice shelves, melt, they do not contribute to sea level rise because the ice is already in the ocean. It's in the water. It's just like a glass of ice water. If you watch that ice melt in your glass of ice water, the water doesn't come over the top of the glass. It just stays at the same level. So that's good news. What about the life along this peninsula. How is it being affected by this very rapid warming? Well, these are Adelie penguins. They look like they're wearing little tuxedos. And my friend in the picture in the back here, Bill Frazier, came down here about 45 years ago. And for his doctoral work, he put 15,000 tags on 15,000 breeding pairs of penguins. And this is what's happened. If you look at the purple line, which is Bill's penguins, you can see that it's going downhill over that period of time, that 45 years. It's going down because these Adelie penguins are disappearing. Interestingly, the penguin in the middle picture on top, called the Gentoo penguin, and the penguin on the top right, called the chinstrap penguin, those guys are moving in. They're moving into the neighborhood as it's getting warmer, because those are warm, loving penguins. And as the peninsula is warming, they're coming down and occupying that part of the peninsula where the Adelie used to be found. So what's happening to the poor Adelie? Well, unfortunately, as the air is warming with climate change, it's snowing more than it used to, and later than it used to. So the Adelie penguins are coming in and laying their eggs like they normally do at the same time every year. And then along comes these unseasonable snowstorms very late, and they cover all the penguins in snow. And then very sadly, when the snow melts, the eggs don't make it. They drown. And so that means that you lose a lot of Adelie penguins. The other thing is that Adelie penguins love sea ice. And sea ice, which is only about 3 feet deep, doubles the size of the continent of Antarctica every winter. Adelies love to get down on their bellies and toboggan across the surface of the sea ice to get out to the edge of the sea ice where they feed on little shrimp called krill. Unfortunately, as the sea ice is disappearing, the Adelies have to swim offshore, and that takes more energy away from caring for their young. So that's not good for them either. And then the little shrimp themselves, we call these krill. We've discovered that when they're teenagers, they live underneath the sea ice, and they eat little plants that grow on the sea ice. And they live here for a period of time. And with the sea ice disappearing, we're losing some of those important shrimp called krill. And there's a lot of things in Antarctica that love to eat krill. One of them is whales, big whales, humpback whales, whales that have big sieves in their mouths called baleen to capture the krill as they're eating. One of the fun things to watch humpback whales do is to dive down and blow bubbles. They blow bubbles in a big ring, and it scares the shrimp, the krill, to come together into a ball. And then the whales take turns lunging up through the bubbles and catching all those krill that have been scared by the bubbles into a ball and coming out of the ocean. And you can see the baleen sieving all those shrimp out. It's really remarkable. The good news about whales in Antarctica is they're coming back. Even though climate change is causing some stress, they're recovering from hunting when humans used to hunt whales in Antarctica. Last year, we saw 50 humpback whales in the same day. That was wonderful. Now, we also know that seals that live in association with sea ice may have trouble as the sea ice disappears. And this is one of them. This is called the Weddell Seal. I love this seal. It has the most amazing thing. The female, the mother seal, has ice chipping teeth. And when she's ready to give birth to her baby pups, she swims under the sea ice and she finds a place that's weak and she starts to chip at the sea ice with her teeth until she gets a little hole where she can breathe. And then she takes her time and she keeps chipping away with her teeth until she has a hole in the ice big enough to climb right up through the hole and lay next to it and give birth to her babies. And what's so fantastic about this is that the leopard seals and the killer whales that might threaten her young cannot get to her because she's been able to find a home using those teeth where they're completely safe from predators. That is remarkable. I don't think the Weddell seals are going to disappear. like the Adelias, I think that they'll probably follow the ice as it retreats. What about leopard seals, these huge seals that feed on other animals like seals? And we have to be careful when we're diving around them. They can be kind of scary. Well, nobody has ever seen a leopard seal give birth anywhere except on the ice, on the sea ice. So nobody knows that what's going to happen when the sea ice is gone. Will they go to shore and give birth or not? The little things in the water, the plankton, the phytoplankton, the zooplankton, are also affected by warming. And there's been a big study to look at plankton up and down the length of the peninsula over the last 40 years. And what they found is that things are changing on the peninsula. The weather is changing. And this is a graph that shows you what's happening between the 70s and 80s and the 90s and 2000s. And basically what this is all saying is the weather is getting warmer. It's getting more humid. It's windier. The ocean is churned up by that heavy wind and the clouds, and it doesn't help the little phytoplankton, the little animals, or I'm sorry, the little plants that depend on light for their survival, that photosynthesize, and they're having trouble. So the plankton is having trouble. What about the forests that live under the ocean? The giant forests of seaweeds. Yes, Antarctica does have forests. You just have to put on your scuba suit, your diving suit, and swim out in front of Palmer Station, and you will be swimming in a forest. Well, I think that with the sea ice gone, these forests are going to do very well. They're going to grow deeper. They're going to grow further down the coast. And this might be something that is helpful for forests. What about the little babies of starfish and sea urchins and corals and all these kinds of things? They're called larvae. This is a baby sea star in Antarctica. It'll swim around for about 4 months before it settles to the bottom and becomes a starfish. As the temperature warms and the water warms, the rate of their development is going to go way down. They're going to develop very, very fast with just a little bit of warming in the water. We know this because we've done experiments on this. And that might be a problem because the larvae like to feed on phytoplankton, and the phytoplankton show up at a particular time. You know, they might show up at the cafeteria and the door is still locked. They won't be able to get in to eat. So this is of concern. And this is just a little graph to show you the rate of development. We don't need to look at that. But I want to show you some other species that are moving in as it warms. The top picture is an elephant seal. And they have arrived near Palmer Station and set up a rookery. They're having babies. You can hear them when you walk out the door of the station now. These are warmer seals that are moving down the peninsula and setting up home near our station now. And on a warm day in the summer, they are really stinky to have laying around the station. The bottom picture are fur seals, and they're also moving in. And then the other thing that's happening is deep in the ocean, as the deep waters are warming, we're actually having some things appear that have never been in Antarctica before. We now have on the slope leading up to Antarctica, this is underwater, we have found king crabs for the first time moving up the slope towards the shallow water of Antarctica. And we're very concerned because king crabs would be the first predators in Antarctica that have a claw, that are able to eat things that are very weakly calcified. In other words, the shells are not very strong, and these crabs could change the whole ecosystem. So we've gotten a big grant to go to Antarctica with this ship. And what we do is we tow a submarine behind the ship up the Antarctic slope in about a 5-mile long transect, taking pictures of the seafloor every 15 seconds. We get tens of thousands of pictures of the seafloor, and we're looking to see if the crabs are there and how abundant they are. And because we have so many pictures, we have to use a very special instrument that scientists use called a graduate student. And they have to work very hard to help us do all this work. And we have found lots of king crabs living on the slope. And also, we have to deal with ocean acidification. And this is where When we put pollution in the air, when we put carbon dioxide in the air from burning gasoline or oil, a lot of it, about a third of it, goes into the ocean, and the oceans are becoming more acidic. And this is a problem if you are a marine animal that makes a shell, for example. The water's more acidic and your shell has to be repaired a lot more. It takes more energy. And this is called ocean acidification. And Antarctica is sort of the place to study ocean acidification because the water's very cold and more of this gas, carbon dioxide, goes into the ocean there because of the very low temperature. So you can go to Antarctica today and look at the shells of little animals like this sea butterfly and see that the shells are beginning to dissolve a little bit. And we've done some work on ocean acidification. This is Palmer Station where I work. And there's about 45 Americans that live and work here. And we've found all sorts of we've studied ocean acidification's effects on shrimp and things. And I just want to say that this community has changed. This is what it's looked like for a very long time with Adelie penguins and lots of things like krill and the seafloor communities. And climate change, climate warming is changing this community very, very fast and in a big way. The Adelie penguins disappearing, and we have new species of penguins, and all these organisms on the seafloor could be affected by different organisms moving in. So this is a big change. That's what climate change does, is it changes things, but too quickly. And when things happen too quickly, a lot of times animals and plants cannot adjust to that change. So very quickly, let me summarize then, and I want to tell you a good story. I want to tell you that there are things in Antarctica we want to protect when we're diving, because in our work, we've discovered that there are chemicals in Antarctic marine animals that can fight things like melanoma skin cancer and the H1N1 flu virus and infections you get when you go to the hospital. In other words, the marine life of Antarctica holds cures to human diseases. We want to protect these animals from climate change. Now, I'm going to tell you a really cool story to end my talk. It's really neat. And it happened in Antarctica. So there were two scientists sitting at their desk, and they sent information back to their boss in England and said, we have discovered a huge hole in the atmosphere, the ozone of our atmosphere over Antarctica. It was so big, the hole in the atmosphere, that it was bigger than Antarctica. It was so big it went over New Zealand sometimes. And it was an important discovery because this ozone protects you and me from ultraviolet radiation. We can get skin cancer if we don't have protection from ultraviolet radiation. And the hole also affected the climate of Antarctica. And what was so neat was that 30 countries from around the world went to Montreal in Canada, and they agreed to regulate the refrigerants, the chemicals that were destroying our atmosphere. And they signed the Montreal Protocol. And now today there are 197 countries from around the world that all agreed to stop producing these refrigerants, these chemicals that were destroying our Earth's atmosphere, our ozone. And it worked. The hole over Antarctica, the hole in the ozone, is now supposed to be gone, disappeared by the middle of the century. So that's what, 30 years from now. And it's a wonderful story. And the companies that made these chemicals did not go out of business. They made new chemicals that didn't destroy the ozone. So that's a story of hope that we can address climate change collectively as all the countries in the world work together to reduce the amount of gas that we're using to get energy and drive our cars and do all these things with. And there's lots of things to replace them, and lots of jobs to be found by doing so. So I'm going to stop there, Joe, and we can have questions.
All right, James, sounds good to me. If you want to hit the screen share, that'll bring you back to us.
Okay, let me see. Screen share.
All right, you're back.
I'm back. Hi.
All right, James. Well, a few things. First of all, thank you so much for sharing that with us. You have a pretty awesome field site that you get to hang out in. It's pretty amazing. It's a place a lot of people don't get to visit, so it's pretty incredible. And then secondly, you know, we always think of Antarctica and the Arctic as these places so far away and so wild. It's hard to comprehend how big of an impact that we have on them. So thank you so much for sharing your research with us today, because we really are impacting them faster than anywhere else on the planet.
That's right.
All right. Well, I think we should meet some of our classrooms, because I have no doubt that they have some questions for you. Okay. So let's get started. Let's see. Where should we go first? Here we go. Let's go to Roscoe, Illinois. We have some fourth graders hanging out with us with Mrs. Pospischel. Let me get their microphone turned on, see how they're doing today.
Question. Okay.
How are we doing, boys and girls?
Hi.
All right. Good looking group of grade fours. Who's up?
Are you ready? Daddy, go.
How many of the king crabs do you think have moved in?
Okay, the question is, how many of the king crabs are now moving up towards Antarctica? Well, we know that they lived in the deep sea around Antarctica for a long time, and now they're up on the slope, and there are millions of king crabs that are on the slope, but they have not reached the shelf yet where all those animals are. So the good news is that they're not quite there yet. We're just hoping that those millions of king crabs, that the water doesn't continue to warm too much and they'll stay where they are.
So James, just to add to that, I'm remembering from your presentation a few weeks ago, one of the major issues is that the invertebrates up on the Antarctic shelf, they don't have those hard shell protections like many others, right?
That's right. In Antarctica, there are no predators that are capable of crushing a shell. So you don't have fish with strong jaws, and you don't have crabs, and you don't have lobsters. So these clams and these snails have very weak shells. I could hand Joe an Antarctic clam, and he could take his 2 fingers and just crush the shell. It's very, very weak. So if crabs move up into that system, they could really cause a lot of trouble. Nothing is protected from them.
All right. Let's see. Mrs. Coburn's class, some 6th graders hanging out with us in the U.S. in Kellogg. Let me get their microphone turned on. How are we doing, 6th graders?
How are we doing? Good. Okay, now you need to talk really loud.
My question is, what is your favorite animal to study?
What is my favorite animal to study? Well, I have to admit that I'm kind of a starfish guy. I studied starfish for my doctoral work when I was in Florida in the United States. And so I love echinoderms, which means spiny skinned animals. So they're like starfishes and sea urchins and sea cucumbers and all those kinds of animals.
All right. And then, James, if I'm correct, another special feature is they follow kind of a pattern of 5, right?
They certainly do. Everything happens in 5s. They have 5 arms, or they have 5 rays. Everything is in 5s.
All right. Very cool. So boys and girls, take a look online and research that, because with the sea urchins and the sea cucumbers, that's harder to see. But if you do a little bit of research, you can see it, and it's pretty cool.
Yeah.
All right. Let's visit another classroom. Let's go to Mrs. Gill's classroom. They're in Canada. There's some grade 5-6 students in Cambridge, Ontario. Let's get their microphone turned on. How we doing, Cambridge?
Good. In your opinion, why does Canada have double the role of climate change as the global average?
Your question is, why does Canada have climate change happening more quickly than other places?
Yes. Okay.
Well, I think that's because Canada is pretty far to the north. And when you go up north to near polar environments, you're not quite in the polar area, but you're just below it. The environment is very sensitive to climate change. If you raise the temperature just a little bit, it has a very big effect. It can affect glaciers that are melting. It can affect sea ice, all sorts of different things that are happening on the coasts of Canada. So you're closer to the polar environment, and that's where you see the biggest effects first.
All right, great question. Let's see, Mrs. Elliott's class. They are joining us. Let me just switch my screen. There we go. Mrs. Elliott's class is hanging out with us from Dallas, Texas. There's some 6th graders. Let's get their microphone turned on. How we doing, Dallas?
Good.
What do you have to wear and take with you when you dive under the ice?
Did you
All right.
did you catch that, James?
Yeah, it sounded like we were diving under the water.
Yeah, a little bit.
Yeah. Good question. So what we do to dive is we wear a special suit. It's called a dry suit. And you wear kind of a warm underwear underneath it. And the suit goes over that. And you have a line connected to your tank on your back. And there's a big button on your chest. And when you push the button, the air from your tank goes into your suit. So you blow up. You look like the Pillsbury Doughboy. And that's what keeps you warm underwater, is that layer of air and clothing that you have under the suit. Now, because you have the air in the suit, you're like a cork. So you have to wear about 40 pounds of weight around your waist to get down in the water in Antarctica. And we just carry with us, we usually carry a collecting bag that we pick up our samples with on the seafloor. We have an extra regulator. That's what you breathe air through, those things that go in your mouth. We have an extra one, because when you're under the ice or you're diving in Antarctica, if something goes wrong, you want to be able to have that extra air right available for you real quick, okay? And especially if you're under ice and you have to get back and come up through the hole. So it's exciting diving. We get a lot of training. We know what we're doing. And it's probably the most beautiful place in the world to dive, because you can see for so far underwater. It's just absolutely stunning. And then it gets very exciting when, say, a leopard seal comes zooming by you, and your heart starts racing, and you think about getting out and getting back in that boat above you pretty quick.
All right, that's a great question. And yeah, definitely sounds like some things to think about when you're diving in under the ice like that. So let's do one more quick swing through. So we're going to go back to Mrs. Michelle's class. We'll see if they have a follow-up question.
Okay.
How much seaweed do you get a year, and what mostly eats it?
Seaweed? How much seaweed is there? And do we, okay, the seaweed that grows off of the station at Palmer, there's a lot. I mean, really a lot. It's so thick that you can't even sort of see through it. It's like you're swimming in the middle of a forest. Yes, there are some things that eat the seaweed. For example, sea urchins like to eat seaweed. And these little tiny crustaceans, they're related to crabs. They're called amphipods. They're tiny little animals, and they like to eat the seaweed. There's even a fish in Antarctica that eats seaweed. So there are predators that eat the seaweed.
All right. Great question. Mrs. Colburn's class, your microphone's on again if you have a follow-up.
How many people work with you?
When I go to Antarctica, there's usually a team of 8 of us. We have 8 people. There's 2 other scientists like myself, and then we take students with us, like college students and graduate students. So part of what we're doing is we are teachers, just like your teacher. We are teaching young people about doing science in Antarctica. And many of these students go on to become scientists that work in Antarctica themselves. So it's a very exciting thing to go into science and become a scientist.
All right. Back to Cambridge, Ontario. Mrs. Gill's class, do you have a follow-up?
In your opinion, what is the worst impact of climate change on biodiversity in your region?
Okay, the question is, what are the impacts of climate change on biodiversity? Now, when you say my region, are you talking about Antarctica, or are you talking about where I'm sitting right now in Alabama?
In Antarctica.
In Antarctica. Okay, in Antarctica, what we're concerned about, I think, is we're concerned about losing some of the plankton, because some of those little tiny animals that live in the ocean are very, very important. They're so abundant, and they feed things like krill, the shrimp. And if the shrimp get in trouble, then lots of different species in Antarctica have a problem. When you have a species that's really important, it's called sometimes a keystone species. And so if we lose any of the keystone species, like some of the phytoplankton in Antarctica, it has a really big effect on the whole community. So that's what we're really worried about in terms of losing biodiversity, are those species that are exceptionally important. That's a great question.
All right, and we'll swing back to Dallas, Texas, to Mrs. Elliott's class. Your microphone is on again.
What advice would you give to middle school students to help teach others about climate change or prevent further damage?
Okay, what advice would I give to school or grade school students about what you can do about climate change? Well, one thing you can do that's really important is talk about it. Talk about it with your parents and your families and tell them that you're concerned, because you're the ones who are really going to face a lot of the effects of climate change. And it's so neat to see students all over the world now that are getting organized. I mean, students in schools are talking about climate change and what we can do about it. And, you know, when you think about it, it's important that we do things individually, that we recycle things, and our buildings are well built for insulation, and we drive cars that don't make a lot of pollution. There's things that you can do. And then there are things that our government needs to do in Canada and in the United States. And that's important to share that story with those people that are in charge of our political systems. So there's all sorts of things you can organize in your school and join an environmental club and do things that really get the word out about climate change. It's starting to really take off now, and I think you guys are going to see a lot of changes coming. I hope so.
All right, absolutely. I hope so too. So James, as we're wrapping up, when's your next trip south?
I'm going back to Antarctica in January, this coming January, and I'm looking forward to it. It'll be my 26th trip to Antarctica.
That's pretty incredible.
And I love it every time.
All right. Well, James, first of all, to our classrooms, a huge thank you for hanging out with us today and for your awesome questions, as always. And then, James, again, thank you for letting us steal some of your time. Thanks for sharing the story with us.
My pleasure.
And, you know, not only what's happening, but some of the good news stories too. All right. Well, I'm going to turn all the microphones on, boys and girls. If you want to get nice and loud and share a goodbye and thank you, we'll sign off for today. So here we go, boys and girls, nice and loud.
Ready?
All right. Thanks, everyone, for hanging out. We look forward to see you in other hangouts. James, you enjoy the rest of your day, and we hope to see you again soon.
All right. Thanks, Joe.
Thanks, everyone.